Solving equations in one variable. Alright, so there weren't notes for this, but there's like two little things here that I'm going to tell you. So we can have an extraneous solution, which is a solution that is not actually a solution to the problem or a solution of the original equation. Most of the time this happens when you have like rational functions and like you get a value for x that works, but it would cause like a 0 in the denominator. And rational equations have the form f of x over g of x is equal to 0. Now obviously they don't always equal like 0 initially. Sometimes we have to move things around to make them equal to 0, depending on the problem, but ultimately that's what ends up happening for us to solve them. Alright, solve the equation algebraically and identify any extraneous solutions. Number 2, we have x plus 2 is equal to 15 over x. So I've got to solve this equation. Obviously, I'm trying to see what x is equal to. So anytime I have something like this where I have like a variable in the denominator or whatever, I would suggest multiplying everything by that so that you can get it to basically not having fractions in the problem. So I'm going to multiply this side by x and this by x. So when I do that, over here I end up with x squared plus 2x is equal to, over here the x's cancel, and I have 15. Subtract the 15, so x squared plus 2x minus 15 equals 0. So that's where the equal 0 part from up here comes into play. And then I just need to see if I can factor this. So can I factor this? And I'll give you a hint if you, not with this problem, but in general, if you can't, you're going to have to use the quadratic formula to solve these. What does this factor into? Yep, x plus 5 and x minus 3. Set each piece equal to 0, so I've got x plus 5 equals 0, x minus 3 equals 0, so x equals negative 5, or x equals 3. So those are my two answers, but I need to check and make sure. Pretty much there's not going to be any issues here because obviously the denominator isn't going to be 0, but I still need to check them. So I have to check each one. So I'm going to plug in negative 5. So I've got negative 5 plus 2 is equal to 15 over negative 5. Negative 3 equals negative 3. So that one's good. And then check 3. 3 plus 2 is equal to 15 over 3. 5 equals 5. That one's also good, so both of those work. Six. 3 over x minus 1 plus 2 over x equals 8. So with this one, these don't have a common denominator, or it's not like the previous one where there was just an x on the bottom. So I'm going to have to multiply the whole thing by both of these things. So I'm going to do this, and I'm going to multiply this by x times x minus 1. So when I multiply this first piece by this, the x minus 1s would cancel, and I would be left with 3 times x. On the second part, when I multiply 2 over x times this, the x's would cancel, so I would have 2 times x minus 1, or you can go ahead and write it as plus 2x minus 2 equals, and then over here I would have 8 times all of this because nothing's going to cancel on that one, so I would have basically 8x squared minus 8x. So then I just need to combine like terms and get everything on one side. So I probably just move it all to the right in this case. So I'm going to have 0 is equal to 8x squared. This is 5x, so minus 13x plus 2. Can that be factored?
No.
It cannot.
No.
So I need to use the quadratic formula. So negative b, so that would end up being a positive 13 because negative and negative is positive, plus or minus the square root of b squared, so 13 squared is 169, minus 4 times a times c, so that's 4 times 8 times 2.
64.
Yep, so I'm going to cross that out and write it that way. And then all over 2 times a, so that would be 16. So I would have 13 plus or minus the square root of 105 over 16. Now, technically, we need to check these, but I know that that's not going to be a value that's equal to positive 1 that would cause a problem, or 0. And so I don't really need to check this one. I'm not going to make you check the ones that are super weird like this. You could by using your calculator and plugging in like the decimal value. But you should be able to see that these aren't going to cause a problem. So both of these answers would work, and I'll let you just leave them together like that. Uh, 10. X plus 6 over x equals negative 7. Ideas on what I should do with this one? Yep, multiply the whole thing by x. So I end up with x squared plus 6 equals negative 7x.
Why wouldn't it be plus 6x?
Because the
Oh,
x
yeah.
cancels with the x. So I'm going to add the 7x over. So I've got x squared plus 7x plus 6 equals 0. Can this be factored into what? X plus 6, x plus 1. So x would be equal to negative 6, or x is equal to negative 1. Plug in to check. So I've got negative 6 plus 6 over negative 6 equals negative 7. Negative 6 minus 1 equals negative 7. So negative 7 equals negative 7. So that one's good. Then negative 1. Negative 1 plus 6 over negative 1 equals negative 7. So that's just a negative 6. So that's negative 7 equals negative 7. So that one's also good. So part of getting all the points on these problems is not just getting the answers, but also checking them. So make sure you do that. All right, overall, those ones are relatively easy, right? So let's get into some that are a little bit more difficult. 14. I've got 4x over x plus 4 plus 3 over x minus 1 is equal to 15 over x squared plus 3x minus 4. So if I have a problem like this, what I need to do is, obviously I still need to multiply everything because dealing with fractions is not something that's really feasible to do. So anytime I have something that's like, these are already kind of like, you could say in factored form, but then this one is obviously has not been factored, then what I need to do is I'm going to try to figure out what my two factors are for this, because a lot of times what happens is it matches these ones and then it makes your life easier. So what could the denominator over here factor into? X plus 4 and x minus 1. That's always kind of a good trick, is try these two and see if that works first, because a lot of times it will. So I'm going to just cross that out, and I'm just replacing the denominator so I don't have to rewrite the whole thing. So then to cancel everything, I'm going to multiply the whole thing by those two factors. So on this first one, when I multiply this first piece by this stuff, the x plus 4's cancel, so I end up with 4x times x minus 1. If you want to go ahead and multiply that through, you can, but I'm going to do it in steps since this one's bigger. Plus, over here, the x minus 1's cancel, so I have 3 times x plus 4. Over here, everything's going to cancel, top and or on this part and the bottom, so I'm just left with equals 15. So then distributing over here, 4x squared minus 4x plus 3x plus 12 equals 15. Combine like terms and move this 15 over. 4x squared minus x minus 3 equals 0. And then can I factor this? Do I have factors of negative 12 that give me negative 1? So 4x squared minus 4x plus 3x minus 3. Factor by grouping. Take out a 4x. I'm left with x minus 1. Over here, take out a 3. I'm left with x minus 1. So I've got 4x plus 3 times x minus 1 equals 0. So then I'm setting each piece equal, but I think you visually can probably just look at it and not actually have to rewrite the whole thing. X would be equal to negative 3/4, or x is equal to 1. All right, checking these now. I've got 4 times negative 3/4 over, if you want to think about it as like negative 0.75 instead, you can do that. It might be easier.
When we're checking these, like on the test or whatever, is that like a requirement to be shown 2 points? Like checking?
I already answered that question, but yes.
Oh, so we can't just put it in our calculator?
I mean, you can after, but you have to like physically, like you need to write down that you've checked it like this. Like on this one, I would probably use my calculator to plug it in, but you have to show that it's like how you've plugged it in. The only reason up here I left it as a fraction is because the 4 and the 4 cancel, so I just end up with a negative 3 on top, so it just is easier when you go to plug it in. I would strongly encourage when you're adding these two things together here that you use the fraction option on your calculator to type it in so that you don't end up with an issue. So somebody type these in like a couple people do this and then somebody else do this side, because you obviously can't type the whole thing in at the same time because your calculator doesn't have an equal option that doesn't solve it for you. So who's doing the left side?
I got
Okay, who's doing the right side? Zach's got it. Cool. And I would like to assume that y'all could do this by hand also, but for speed, I'm letting you do it on the calculator. What'd you get, Zach?
Like -2.637.
Okay. Shepard, did you get the left yet? What'd you get?
that is the one. I mean, -2.637.
Yeah. And depending on if you're obviously, these are like decimals that just are like 0.75. If you had like 2/3, you are not going to be able to type in like 0.66 and it necessarily work out exactly. It's going to be really close. I mean, as long as it's like within a couple decimal places, like it's fine. All right, now I need to do the same thing but with +1. Now, let me go back up here. What happens as soon as I plug in +1?
You go to 0 on the bottom.
Yep. So I don't even need to check this one. I can go and write extraneous. If you want to write the reason, okay, you can say 0 in the denominator. So the only answer that actually works is -3/4. We are jumping to a word problem that goes with this stuff. It is an odd one, but we need one to do, so. All right, 35. Consider all rectangles with an area of 182 feet squared. Let x be the length of one side of such a rectangle. So I'm going to go ahead and draw a rectangle here. And I'm going to say this is x. Express the perimeter as a function of x. So, what's the equation for area of a rectangle, first of all?
Times width.
Yep. Just trying to get my thingy to work. All right, length times width. Now, what about perimeter? Because ultimately I'm trying to find perimeter. What's the perimeter of a rectangle?
2L plus 2W.
2L plus 2W. Now, if I only know one side of my rectangle, and I'm assuming that it's, you know, the small side, that really doesn't matter. It's just a visual thing here. And I need to find the, in this case, the length of it. Any ideas how I might go about finding the length if I only know one side? Like, how would I find the other side length? 182 over x. Because if this is 182 and I know that the width is x, so if I have 182 is equal to L times x, then the length has to be 182 over x. So I'm going to put that in here. So now, in this equation for perimeter, I'm going to replace length with 182 over x, and I'm going to replace the width with x. So I end up with P equals 2 times 182 over x plus 2x. Now, I'm writing perimeter as a function of x. So unlike our previous equations that we were doing where I was multiplying the whole thing by it, I just need to multiply and get a common denominator on the right-hand side. So this is going to end up being, what is that, 364? So I'm going to have, well, let me do this. I'm going to multiply this by x over x because I need an x in the denominator here. So perimeter is equal to 364 plus 2x squared all over x. So that's the equation for perimeter as a function of x. Then part B says, this was A, part B says to find the, nope, I'm reading the wrong question. Find the dimensions of the rectangle that has the least perimeter, and what is the least perimeter? Ideas on how I would find this?
Multiply everything by x.
Well, I don't know what the perimeter is yet, so I can't really do that.
Isn't that the perimeter?
What? I know the equation, but I don't know the perimeter. I have too many unknowns right now.
What's the question?
I'm trying to figure out what the least, the dimensions of the rectangle that has the least perimeter and what that value is. So I need to find x and 182 over x, and then I need to actually find the perimeter.
You can plug random numbers in.
If x.
That only is going to work if they're perfect numbers.
If x is equal to 1, then it's
Well, we
366.
don't know if x is equal.
How about we graph it and find the minimum?
Oh.
So type this into your calculator.
What's the y?
Okay, Zoom 6 isn't going to work. How do I, what's happening?
Ma'am, it didn't pop up with anything.
Because Zoom 6 isn't going to work because the graph is too big.
Can we zoom out?
Huh?
Can we just do zoom out?
I did Zoom Fit, but yeah, that should work.
Okay.
You just might have to do it a bunch of times.
These two brackets. And then we do second trace. Minimum.
Why is this not working? What is going on?
1.06. 344. Just on either side of the graph. I did second trace. Left down, I don't know.
This normally gives me, something's not working right, so one second. I mean, y'all can keep trying to do it, but mine didn't work. So I need to look at something.
How did I get? I got 31 billion.
I got 5. But yours is probably right.
Mine's just 31 billion.
I don't know why this is not working. What is going on? 35. I may have just made you do a whole bunch of work that you didn't need to do. Hold on. Yeah, I did. What's the smallest type of rectangle we can have?
A rectangle.
Square.
A square.
Oh, I got it right. I broke my pencil.
You're so excited you broke your
Chuck it.
pencil. So if the smallest rectangle is a square, what would have to be true about the sides?
They're all equal.
Now, what's the area of a square?
S squared.
How do we know this is the smallest rectangle though?
Because they have equal sides, and a rectangle has typically one side is longer than the others. So if they're all the same, that it can't be any smaller than that. A square always has to be the smallest version of a rectangle.
Right, but did the problem tell us that we're looking for the smallest version of the rectangle?
Yeah, it says find the dimensions of the rectangle that has the least perimeter. So in it, you had to infer that a little bit.
Okay.
So the calculator way was really unnecessary because it's not gonna, like, it's not gonna get you to the end result that you're trying to get. So I can take the area and take the square root of it because then that'll give me the side, right, of a square. So we're gonna take our 182 and take the square root of it, and that's gonna be equal to my side. And when I do that, the square root of 182 is equal to 13.5.
That was close. So now we know that x is equal to 13.5.
Mm-hmm. Yep.
And then we divide 182 by 13.5. And that gives us, that's so freaking smart.
So x is 13.5. Then we're going to take, and that also means that my width has to be that. So we could say this is our width. My length also has to be 13.5 because it was a square. Multiply that number either by 4 or use your 2L plus 2W. Or we can plug it into this formula over here. Up to you.
Wait, why do we have to do all that? Why can't we just do x equals 13.5 and then 182 divided by 13.5?
That is what I did. I found the length and the width, but it says it wants me to also find the perimeter.
Can't you find the perimeter by not having to use that big old number thingy for p?
The formula? Yeah, I just said there's multiple ways I can do this. I said
Okay,
I can
that's
either
awesome.
use the area of a square because a square is the least rectangle, or I can use the 2L plus 2W
Okay, that makes sense.
and plug in these two numbers for it, which you're going to get the same thing. I would probably just do 4 times 13.5 and get that value, which I didn't multiply that value yet.
Because the perimeter of a square is 4
Now, obviously, I rounded to 13.5. If you were to look in the book, they did not round, but so this would be the perimeter. These are the dimensions.
But it's easy. What's a vocab?
May I use the restroom?
After I'm done with the next problem. All right, last problem, 37. Drake Cannery will pack peaches in a 0.5 liter cylindrical can. Let X be the radius of the can in centimeters. Find the surface area S of the can as a function of X. And then find the radius and height of the can if the surface area is 900 centimeters squared. So we have a 0.5 liter cylindrical can. I mean, yes. They're specifying that, though, because the formula has to be for a cylinder.
You said 8 point.
No, I said 0.5.
So 0.5. Oh, and that says liter.
The radius is X in centimeters. So I'm going to draw my can. Whoa, not a sideways can, though.
No. Wow. You should, never mind. I was gonna say you should teach art class, but this isn't looking very good.
What is happening? I'm going to draw my two sides, and then I'm going to draw my...
Patent delivery service.
Do you like hard candy?
Oh, thanks.
She said, she's saving the plates. If you, I laughed. I said.
Well, I have to have some way to take mine home, because
Yeah,
I'm
well,
not
that-
eating it right now.
That's fine. I just said, yes, I can play delivery. Oh, your
Thanks.
little cup looks cute.
Thanks.
It's a canister,
It's a can of peaches.
is it?
Hmm
I thought we were talking about beans.
Well,
You think I said 8.5? You think I said beans?
8.5 is my favorite number.
Wait, what happened to my orange? I don't know. I was trying to make it orange. Did I click yellow?
Are peaches yellow?
I'm yellow.
Peaches. I think they have white peaches. Peaches is that thing from ice cream.
I love how this is detrimental to our math problem.
It is.
Isn't that what they named the baby yellow? Peaches.
Is it?
Peaches is a cow at a farm in Virginia Beach.
Oh.
Peaches. I think the ice age one's cool.
All right, so this is more going to be a fun fact for you, but 1 liter is equal to 1,000 centimeters cubed.
You were really off, Ryan.
I said 6.
Yes,
So,
it was in a gallon.
0.5 liters is 500 centimeters cubed then. Does anybody know the formula for volume of a cylinder?
Oh,
Base
no,
R squared.
no, pi r cubed.
Pi r squared h. Pi r squared is the formula for
The circle.
a circle, and then the volume comes with the height of it. So I know that the volume of this can is equal to this value here. I'm doing it in centimeters because ultimately that's what they want my answer in. So I'm going to set this equal to 500. Now, the radius is x for our equation, so I'm going to replace that with x.
Figuring X, right?
Are you alright, Mason?
Yeah.
All right, now, does anybody know the formula for surface area of a cylinder?
No.
Or anybody want to guess?
It's like a
Pi
rectangle.
R squared plus
Yeah, I'm going
R
circumference.
H.
thought it was just a rectangle.
Yeah, I don't think I've ever seen.
Oh, yeah, yeah. Two
Wait,
pies.
is the surface, what's the surface area? Does that mean just like the can, like the outside can part?
The outside, yeah.
Oh, okay.
So the 2 pi r squared is because we have pi r squared is a circle, but I have 2 circles, so I need the area of both of them. So that's where this part comes from. The 2 pi r h gives you the outside of the can going around. Now, I obviously know that r is going to be x from my equation. So I'm going to replace these with x. So I'm just going to do this. Now, I have an h in here, but I don't know anything about h, so I need to get this over here because I'm doing it as a function of x. I'm going to solve for h over here and then replace h in this equation with whatever I get over here. So this is going to be 500 divided by pi x squared is equal to h. I'm going to plug this in here. So I have s is equal to 2 pi x squared plus 2 pi x times 500 over pi x squared. At this point, I would see if I can cancel stuff. Right here, I would cancel pi's. I would cancel one of the x's out of the bottom here. So my surface area formula is 2 pi x squared plus 1,000 over x. So that's the first part that they're asking us for. The equation of surface area as a function of x.
Wait, what? So we're not just multiplying 500 over pi x squared by x, we're doing it by 2 pi x?
Yeah, all
So
that's
would
being
2 pi
multiplied.
x need to be in parentheses or no?
I mean, that's just all one unit, so.
Okay. Okay. Okay.
All right, then the next thing they want me to do is to find the radius and height of the can if the surface area is 900 centimeters squared. So that means I'm going to take this equation, set it equal to 900. This was A. So I've got 900 is equal to 2 pi x squared plus 1,000 over x. And now I just solved this like the problems I was doing earlier. So we multiply by x on everything. So I've got 900x is equal to 2 pi x cubed plus 1,000.
Thanks. Set it equal to 0.
Yeah, move this over. So I get 0 is equal to 2 pi x cubed plus 900x. Plus, yep. I'll do that in a second.
It is factor.
Is it?
I hope so.
It's so cute. So they can still be factored. They can keep it 2 out.
I would recommend probably graphing this and finding where it crosses the x-axis.
Where's pi?
Second.
To the cubed minus 9.
You know, I'm really glad to have math fourth period because I just don't think I'm awake enough for this morning.
Zoom.
Why not?
Didn't you go to bed at a decent hour, Charlotte?
No, I didn't actually.
She was up
That's
milking the cows.
austere.
It's 1.063.
What does austere mean?
It's one of our vocab words. that
Severe or
makes it-
stern in manner.
Well, it gets basis, man.
Mine is just a straight line.
Yeah, where it crosses X.
It's got like 3 lines.
Cash.
No, Cash.
What are you
You gotta
doing?
zoom out a little bit. It's got 3
Zoom
lines.
out a little bit.
Cash, I think you're wrong.
So use the second trace 0 function to find out where it is.
You said second trace is in?
0.
Second trace 0. Oh.
I mean, it looks to me to be somewhere between 0 and 2. It could be right on 1, but you need to check and see
Which axis do we want to?
the x-axis.
It won't let me ask where my thing is. Like I can't see where my.
Yeah,
Just
I
look
don't
at the
see
numbers at the bottom for x and go from where x is like 0 to where like x value is like 2. Just watch that part. So I get x is 1.12. So that would be centimeters. So that would be the radius value.
Where did we get 1.12?
It's where it crosses the x-axis. If you graphed the function, hit second trace, 0, and then you're not going to be able to see the little thing moving on your graph. So you're going to have to look at the x values that pop up at the bottom of your calculator. I can tell just looking at my graph that it's between 0 and 2. I mean, I'm pretty sure it's somewhere closer to 1, but I'm going to do that so I have a wide range. And then I'm going to take that value and plug that into this formula for H. So 500 over pi times 1.12 squared.
This problem feels very like roundabout.
I mean, they kind of are. They're like approximate, yeah. So I get an H of 126.9 centimeters then. That is a ginormous can. That's like a huge can.
It's
All right.
ridiculously large.
I guess it's one of the Sam's Club cans.
That's like, what are you drawing? Just call it a tile.
Teachers to feed the whole community.
All right, your problems are 5, 9, 11, 13, 15, 25, 29, and 40.
You know what one's about, right?
In 3 minutes.
Just for my version.